We're going to talk a bit today about Sitecore and Kubernetes. My name's Rob Earlam, and I've been working with Sitecore for, about 5 years with the company, but about 14 years in total with the actual software. So let's dive straight in. What is Kubernetes? Well, this is how the official Kubernetes documentation describes it. It says Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation, and as a large, rapidly growing ecosystem. Kubernetes services, support, and tools are widely available. It was originally open sourced by Google back in 2014, and you may sometimes see the name written as K8s, like it is in the title here. And what that basically is that it's a contraction because there's 8 characters between the K and the S, and Kubernetes is quite a long name. Okay, so that kind of paragraph is a pretty abstract way of describing Kubernetes. It's not amazingly accessible to show what it actually does. So let's take a look into why you'd actually need it. Well, containers are a really good way to bundle and run your application. But in a production environment, you need to manage those containers, the applications, and you need to ensure there's no downtime. So a good example of this is if a container errors or it goes down, you need another container to start in its place. Kubernetes basically provides you with a framework to run container-based architectures in a resilient way. So it has a series of features that allow for that. Service discovery and load balancing basically allows you to expose a container using either a DNS name or their own IP address. If traffic to the container is high, Kubernetes is able to load balance and distribute that network traffic so that your deployment remains stable. Storage orchestration. Basically, Kubernetes allows you to automatically mount a storage system of your choice. That could be local storage, it could be public cloud providers, and many others beside that. It allows for automated rollouts and rollbacks. So it basically works with the concept of desired state. And we'll take a look into all this in a little detail shortly. But what you do is you pass a set of configuration elements over to Kubernetes, which specify how you want your system to be set up. Kubernetes will then change the current state of the system to match the desired state, but crucially, it does it at a controlled rate. So, for example, you can automate Kubernetes to create new containers for your deployment and also remove any existing ones. So it does all the tidy up for you as well. It's also self-healing. So Kubernetes will restart any containers that fail. It'll replace containers. It'll kill containers that don't respond to user-defined health checks, and they're defined by yourselves. And also, it won't open containers as available for traffic until it's actually ready to serve traffic. Finally, also secret and configuration management. Kubernetes lets you manage sensitive information, things like passwords, OAuth tokens, SSH keys, and you can deploy and update secrets and application configuration without actually having to rebuild your containers. And also, that means you don't have to expose your secrets in the containers directly. So with Sitecore, think of things like connection strings and license information. It means you don't have to hard bake those into your containers. So let's start to take a look at some of the key concepts that make up a Kubernetes infrastructure. The first, the cluster. That's basically like the foundation of a Kubernetes setup. All the other objects we're going to talk about are deployed within a cluster. All the applications we build run on top of that cluster. Inside the cluster, it's basically made up of a series of nodes. And a node is a worker machine. So this could be a VM if you're in Azure, or it could be a physical machine that you actually stand up if you're deploying these Kubernetes out to bare metal. You also have the concept of a pod. And a pod it's the smallest deployable unit in Kubernetes. And it will contain one or more containers. And each time you create a pod, it will have the same containers within it. So if you had 3 instances of this pod, it will have, each of those pods will have the same 4 containers, basically replicated within each pod. We have the concept of a deployment, and this is where this concept of desired state comes in. A deployment is basically a set of configuration elements, which basically say, as it says here, I want 3 pods running my application. That's an instruction you're giving to Kubernetes. Kubernetes will then take that and it will go and create those 3 pods to match your specification. And we have the concept of a container. I'm not going to go too much into containers today. There's heaps of information around what containers are, how they're built, and the benefits you get from them. But basically, what you do need to know is that containers are the technology that kind of underpin Kubernetes. Kubernetes is an orchestrator for managing containers. You have the concept of a service. And a service provides an abstract way basically to expose your application running as a set of pods. So it means that pods and containers can communicate with each other internal to your cluster. And it also allows a way for you to expose your service externally. And those services, when exposed externally, will go through what's called an ingress. Typically a reverse proxy, something like Nginx. And that is basically how you expose these out to the actual outside world. So you'll get, when you go and hit your CD or CM, like we'll look at shortly, the traffic's going to go through an ingress into a service, and then finally it'll hit a pod, and then a container within the pod. We also have the concept of namespaces, and these basically provide a way to logically group elements in Kubernetes. I kind of like to think of these almost like a resource group in Azure, as in you're grouping elements that are related together. And it can provide a good way for you to share a cluster between multiple instances. Say if you have a non-production cluster used for your non-prod sites, you may have 4 or 5 instances of Sitecore running on there, and you'd probably group those off by namespace to keep them all logically contained together. Secrets are the last kind of element I want to talk about. And as I mentioned, you don't really want to store things like credentials, passwords, API keys, and other secrets in your source control repository or in your containers, because it makes them really difficult to change those at runtime should the need arise. We've all had the issue with an expired Sitecore license, obviously. Instead, you want to store those images and pass them in at, store those externally to your images and pass them in at runtime. With Sitecore, yeah, as I said, these are things like database connection details, ID secrets, certificate details, license information. The other advantage to passing them in at runtime is it means you can use the same image you build for all of your different environments. You don't have to build an image for staging and a different image for production. It's exactly the same image you use for both, which gives you the confidence that what works in production, what works in staging will work in your production instances. Okay, so it's still seeming a little abstract here. Let's start to take a look at how these different elements interact with each other. Well, you start off inside your cluster with a control plane, and you'll have 1 or more instances of this to provide high availability. Next, we have a series of nodes, and this is where our containers will run. Each of these nodes contain a kubelet, which is what the control plane uses to control the node, and it contains a container runtime. In our case, that's going to be Docker. So we start off by telling Kubernetes we want to create a deployment. So we're going to pass some configuration over to Kubernetes, which is going to tell it the desired state we want it to create. This deployment will create a number of pods to be created. Each pod will contain 1 or more containers. And in this case, we've got a single container represented by the black icon, and the blue icon, the blue border represents the pod itself. Finally, we'd create a service-let deployment, which assigns it an internal IP to allow other containers and elements to communicate with it. But this deployment could contain multiple pods. In this case too. What happens then is Kubernetes will scale these pods across the nodes. But notice how the same service still wraps both of them. So the traffic will be load balanced from that IP address between the 2 pods. And you can continue to scale this out further. Here we have 5 pods, creating an instance, all with a single container inside. But notice, all still wrapped by that single service. So that's talked a little bit about what Kubernetes is. But a lot of the documentation we've talked about so far with Sitecore is referencing AKS, which is Microsoft's managed Kubernetes service called Azure Kubernetes Service. And that provides some good benefits on top of standard Kubernetes. You could basically almost think of it as like a PaaS version of Kubernetes. So you get things like elastic provisioning. So it's underpinned by virtual machine scale sets. So that means you can have the amount of compute resource available to your cluster automatically scale up and scale down depending on resource utilization within the cluster itself. It's got a really nice integration with VS Code. So you can go and see all of the different Kubernetes elements you have set up in AKS, all deployed directly into, shown directly in VS Code. We have identity management tightly integrated through Azure Active Directory. So if you're already using AAD in your stack for identity management, this is going to slot in really nicely alongside of it. It's available in 36 regions and growing, so across the globe. And crucially, you can set up both Linux and Windows nodes, which for Sitecore is very important. So that brings us to Sitecore and AKS. So what is available today? If you go to dev.sitecore.net, you can get a full set of Kubernetes specifications. They are ready to download, and you get a full installation guide walking you through how to deploy a Sitecore instance to an Azure Kubernetes deployment. Do you want to touch a little bit on what is and isn't supported? So all of the application containers we provide, so things like your CM, CD, Xconnect, all those different roles, they're all fully supported. You can deploy them today. If you have any issues, you can go through the support portal and you'll get full support. We do have some data storage containers, which we're going to touch on shortly. So SQL, Solr, and Redis. Those are non-production images. So that doesn't mean you can't run them. You can't run those roles as containers in production, but you're going to have to build your own images to do so. Another key to note is they need to be in a separate node pool compared to your application images. So a node pool is one group of nodes that can be scaled horizontally. And it kind of makes sense to scale that out separately, especially on Azure. They have different VMs designed for different purposes. Your application node pool would probably want to be more processor heavy because that's going to be where its workload is. Whereas your data storage containers may want to be more disk load heavy. So you'd want to have a specific node pool designed for that specific workload. Okay, so that's a heap of slides with loads of Kubernetes terms. Let's start to take a look at some of this in action. Okay, so let's go into VS Code first. So I have this Kubernetes folder here. And inside here is basically an exact copy of what you will get from dev.sitecore.net if you go and download the Kubernetes specifications. This is what you'll see for an XP instance. I'm just going to go through some of these different elements. I'm going to start with the secrets. So as we mentioned before, secrets are there so you don't have to bake secret data into your containers. And you can see there's loads of things in here which you're pretty used to when working with Sitecore. So things like database passwords, database usernames, you've got the actual database itself for the password. Things like identity certificate, so to secure the traffic that goes to the ID server. Your licensed information will have to be base64 encoded and put into the secret file here. And there's heaps of other ones, but they're all pretty easy to populate. We then have this customization.yaml, and this is what basically groups all these together and is what's going to be read by Kubernetes. So we'll push this into a Kubernetes instance, and what you end up with then is basically secrets that are grouped together, and they're grouped by logical function. So things like Sitecore admin holds the admin password. There's only one secret in there. That makes sense. You end up with a secret collection now called things like Sitecore database, and that will contain all the different secret values for our database values. One's for our identity certificate, for our license, and they're just grouped logically to keep things that kind of should live together. Okay, so let's take a look in external. So these are the data processing rules, which I mentioned before. We have things like SQL, Redis, and Solr. Let's take a look at SQL first. I'm just going to drop past the first element. So these are all YAML documents, and you basically get multiple Kubernetes objects defined in each YAML document. So I've dropped down a little bit first. We'll go back to the top section in a second. But the first bit I want to point to here is a deployment. So we start off by specifying the API version, and here we're going to define a deployment. So remember that is a desired state that we want Kubernetes to create. So we're going to tell Kubernetes, right, I want you to set this up for me. We provide some labeling so we can reference things easier. And here's where we're going to specify what we actually want created in the spec. We specify the count, so how many. I only want one SQL role. Give it some more labels. And here's where we start to get to the actual interesting piece. We're saying this element has to run on a Windows node. So when you create an AKS instance, you will always have a Linux node because that's what the control plane runs on. You can't just have Windows nodes. Because of that, you need to have this node selector to say that this SQL image runs on Windows. Otherwise, it might mistakenly try to deploy it to a Linux node, and then it won't work. After that, we get to our container definition. So here you can see we're pointing to the standard non-production SQL container image that Sitecore released. And here's where we start to pass in our secrets. So you can see our SA password. So we can say it's a value from a secret reference. Sitecore database was the group name in that customization YAML we looked at before. And then we're going to basically pull out the name, which is the Sitecore database password. We do things like accept the EULA as well. And that is all the YAML needed to define a deployment. If we jump back up to the top bit, you can see what we also define in here is a service. So remember, that is what wraps the pods that get created to enable them to be communicated with by other pods within the Kubernetes cluster. Again, we provide the same labels. And here, all we're doing is basically saying, expose this app on TCP on port 1433, the standard SQL port. I don't want to save any changes. So let's take a look at Redis. We're going to go through a few of these now, and you'll see that they're all really very similar. Here we have our Redis service. We define the protocol and the port that it's exposed on. And we can look down here. We have our labeling again. We have a single Redis instance. And this time we're deploying out the Redis image itself. Much the same way for Solar. We specify the Solar service with the Solar port it's going to be exposed on. We're specifying it needs to go to Windows. And here we have our Solar image that's going out. The next ones I want to look at are a little bit more different. So these are called the init images. And these are basically used to initialize these data storage images. Well, the SQL and the Solar one anyway. So those images that we looked at, this SQL image, actually doesn't contain any Sitecore data. What it is we take the Microsoft SQL image and we add some scripts in there to help with things like health checks and other things. But we don't actually create any of the tables from the start. So that's what happens in this MS SQL image. And these are defined as a job. The job is basically a pod. It's a special kind of pod that gets created with a single purpose. It'll run to completion and then it'll exit automatically. In this case, this is going to run and create all of my SQL containers, all of my SQL tables for me. And you can see we point to this init image, and here we're passing in heaps of different secrets all the way down. The Solar init is there to create all of my Solar indexes inside the Solar container, much in the same way the SQL init contains the SQL tables in the SQL instance. If we then look at everything else just in the root of this Kubernetes folder, here's where we get all of our actual application definitions. So we have things like our CD instance. And again, they're all looking very similar. We have our service for our CD. It's going to define on port 80 because that's what it's going to be exposed on. And here we go down. I'm only creating one CD instance currently, but if I wanted to have this load balanced and have two CD instances, it's just as simple as basically changing that definition like so. We go down and we have some more spec information. The init containers I'll come back to shortly. But here you see we're specifying the CD image, and we're specifying all of our different secret data again. And this is the same all the way through. I'm not going to go through all of these. But again, ID server, your identity server, you got your service, your deployment, and you can see it's basically just heaps of YAML. That's what it is to define it all and get it all up and running. So let's start to deploy some of this. So I'm going to hop over to PowerShell. I'm in that same folder, that Kubernetes folder, and I'm going to start by deploying my external images. That's the first ones I'm going to do. So to do that, I'm going to use kube control, which is the CLI for Kubernetes. I'm going to say apply, which is going to apply some of my configuration. It's file-based, so I'm going to use the -f flag. And I'm going to deploy everything in that external folder we looked at first. So the SQL, the Redis, and the Solar. And you can see it gives you an output. So you can see it's going to do the SQL service. It's going to do the SQL deployment. Redis service, Redis deployment, same for Solar. So we can go in, use the CLI again, and we can now say, okay, get me my pods. So show me what you have running in the default namespace. And you can see I now have my SQL, my Redis, and my Solr, and they're both running. This replica set, the count, is what we define. So I said I wanted one SQL, and there's one of them that's ready to receive traffic. And it hasn't been restarted yet, and it tells you how old it is. So let's go ahead and run those init containers. That's the next thing we need to do. So we're going to go apply again. These are file-based. And we want to go and apply init. That's going to create my two jobs that I just set up and just walk through. So the SQL init and the Solr init. So if we go and get our pods again, we can now see we have two new ones. The SQL init's there and it's creating the container. The Solr init's there and it's creating that container. It's going to take a couple of minutes to run through. So let's take a little bit more of a look at this CLI. So this is basically how you can get all the data about your Kubernetes cluster and what's running in there. So we can, for example, look at the namespaces. We can see what namespaces we have. We have our default namespace, which is what we're deploying into today. We have some standard Kubernetes ones, which you don't really interact with too much. And the ingress one as well. I will just hop back to VS Code. I forgot to go through that. We do have a definition of our ingress settings here. So, what is this one? Yes, so these are basically defining the external access for our Sitecore instances. So here you can see we've basically set up a rule for this host header, cd.globalhost. When any traffic enters my ingress on that host header, this is going to say, right, forward it to the service called CD on port 80. And that was the service that we configured in here, remember. We had a service called CD listening on port 80. So that is basically how the traffic gets mapped from your host header into the specific service it wants to access. And we have the same for ID, the same for CM. And what we're doing here is basically we're just mapping a encoded certificate out of our secrets to be used to secure that traffic as well. Okay, let's see how those pods are going. So, Solr's happened super quick. That one's really fast to go through. So, another thing we can do while we're here is we can actually start to get some log information. So we can go kubectl log, and if I just copy that pod name, we can actually get logs. We can get some information about the basically logs from the standard out for that container. So we can see it's gone through, it's created a series of stop words in here. And it's gone through and created all of our different indexes. So all the indexes you're used to in Sitecore, core, master, web, all the different XDB indexes, everything you need to set up a Solr instance. So let's go kubectl pods. Let's take a look at these again. So, okay, SQL's still running. So let's see what that one's up to then. Again, we can go kubectl logs. This time I'm going to use the follow flag because it's still active and I want to tail the logs to get a continual output of what's actually happening. Let's drop SQL in. Okay. And here, if we scroll up a bit, we can see it's creating all the different tables we need. What's this one? Sitecore.web's been created. So you can see if you've ever dug through the Sitecore databases before, all these table names will be pretty familiar to you, doing all the indexing work. We're down to XDB collection. And this happens alphabetically, so we're on X, so it should be fairly close to the end now. And as I said, this is basically connecting to the SQL Server instance, running inside that SQL container, and it's creating all those tables. It finishes off by just creating all the users that we need to access them. And the Sitecore admin password, and there we go. So if we go back to look at our pods now, it completed. You'll notice the log stopped tailing and it just kicked me back to the command prompt automatically. And that was because the container completed. The job finished. And so it just booted me out. There was no more logs for us to watch. Okay, so we've deployed our external containers and we've initialized them. So our data storage roles they're ready to go. So I think it's time we need to deploy our actual application elements. So again, we'll go kubectl, apply. We're going to do some file-based applications again. And then we're going to do basically a dot. To remember all the application ones, we're just in the root of this Kubernetes folder. And you can see heaps of stuff come out. So here we have our service for CD, our deployment for CD, for CM, Cortex elements, ID, processing, all the different Sitecore things you're used to seeing. So we can once more go and get our pods. Oh, there's loads now, loads of stuff going on. Okay, again, this is going to take a few minutes to do. So in the meantime, let's go and take a look in the Azure portal. And I just want to show you what AKS looks like from this side. So I've got this resource group here called SUG Pittsburgh. And here you can see I have a container registry. And if I was building my solution, I would be pushing my images into that container registry. And I have my AKS instance. But you'll notice I also have this other resource group. When you use AKS, you'll end up with an extra resource group that gets created that basically handles and contains all the different Azure elements that underpin the AKS instance. And you can go and take a look at them. These are all pretty standard Azure elements. You can see things we have like Azure virtual machine scale sets. So that's my set of Linux scale sets. I then have my Windows scale sets. So that's the nodes that are underpinning the AKS instance. We have the public IP address, which is my ingress. That's my Nginx instance exposed to the outside world. And then we have various other different networking and security elements. So you can see it's pretty standard Azure technologies, which are being used to underpin this AKS instance. But let's hop back to the actual AKS instance in here, because this is where we start to get a little bit more information. So I want to start off by looking at the nodes. As I mentioned before, AKS provides you with elastic scaling, which is one of the great benefits of this. It's super easy to configure. Here you can see I have my Windows node here. And all you need to do is you can go into the scaling settings. Currently, I have it set to manual. I just have one node. That's all I need for this. But if this is a production environment, you can switch it over to auto scale. And then you can say, I want a minimum of 265 nodes and a maximum of 842. And these are 8 CPU, 32 gig machines. So that's a heap of computing resource you can throw at it. I'm not going to click apply or my boss will shout at me a lot. So I'm going to cancel that. But you can see it's really easy to configure. As simple as that, just a slider, just as you would do when you're configuring like an Azure PaaS web app. Anyone who's used Kubernetes previously or seen any of my earlier sessions might have seen me show the Kubernetes dashboard. So as of AKS 1.9, that is no longer supported with AKS. It won't work. So they kind of want you to use the resources view in here instead. And you get this section in here where you can go and view basically what's happening in your cluster. And this is kind of as an alternative to the CLI, which we were using before. Here we can see the same namespace information. We can go through and view the nodes itself. So here we can see, sorry, the workloads, not the nodes. So here we can see all the deployments. I can go and see the pods that are created. Let's refine that just to the default one. And here we can see all the different XP elements that were required. We've got the data storage roles here, which were running. We've got the 2 initialization jobs, which completed. And here we can see the various XP application elements coming up. So you can see some of them are coming up now, some of them are waiting. The interesting thing I wanted to point out, though, is this init 1 of 4, init 3 of 6. What that basically means is that these pods have a dependency on another pod, and they won't start until those other pods are reporting as ready to receive traffic. So if we go and take a look in the CD instance, here you can see we have these init containers. So you can see it's waiting for 4 of them. It says XDB collections completed. So terminated, ready, true, that one's fine. XDB automation is running. However, it's not ready. So it's not ready to receive traffic yet. So that hasn't been passed. And automation reporting and reference data, they aren't even created yet. So we're still waiting for those to come up. If I hop quickly back to VS Code and my CD instance, this is where the init containers I skipped over before are defined. So what we're doing here is we're basically checking the health Z command to check that the container is ready for XDB connection, automation reporting, and reference data. So that's where that concept of the init is defined. Okay, so let's hop back to my pods. Let's see where we're getting to. Not namespaces, workloads. Okay, oh, we're looking a bit better now. These are starting to come up. So this is okay. I don't mind going through the Azure portal, but you may not want to give everyone access to the Azure portal to view this. Like you might want to lock that down. And that's where the Kubernetes dashboard was quite useful. But luckily there are alternatives. So I want to show you one called K8 and I basically installed it into my Kubernetes cluster before. It's just one line command to set up the different deployment and services for it. And what I'm going to do is now I'm going to do a port forward. So what I'm saying here is I'm using the kube control API. I'm forwarding a port to a specific service. So there's a service called K8-, that's the name of the dashboard. It's in the kube system namespace from the -n flag. And what I'm saying is I want to map traffic from port 9999 on my local machine to be forwarded to traffic on port 80 inside that K8- service. So we can go into a browser again. I can go localhost 999. And here we go. We now get a proper Kubernetes dashboard with some pretty simplistic pie graphs. But if you're a person who prefers to use a GUI over a CLI, this could be really helpful. So here we go. We can take a look now. And we can see all these pods are now active 1 of 1, 1 of 1. How old they are, about 6 minutes old. Oh, we've got the SQL ones that are a little older. I think they're all up now except for the CD and CM. So let's take a look at CM. Let's see what we're waiting for here. So that's still going. Back to CD. And you can get a lot of information about what's actually happening. So here we can see all the different environment variables, how it was configured, the ports it's listening on, its replica set, and how many times it's restarted, the deployment is tied to. Lots of interesting information for sure. Tell you what, let's bring up another window here and let's see what's actually going on. So we can go into here and we can say, get me my pods again. Okay, so we can see they're running, so they're coming online. They're just not ready yet. Let's take a look at the CD one first. We can go to control logs, tail it again. Ah, here we go. So we can see all our typical Sitecore logs. So we know it's up and running. Oh, the health C's been hit. It's got 200 now, so it should be back pretty soon. Ah, CD's up and running now. Okay. I think that one other thing we should look at while we wait for CM is probably the ingress. So remember we looked at the ingress YAML before, and that specified the host headers and how that was going to map through to the service. Well, again, we can view that from the CLI. So we can go kube control get and ingress this time. Show me all the ingresses that are defined here. We can see we have the Sitecore ingress I configured before. We have the different host headers defined in there. So CD global host, CM global host, ID global host. And crucially, this is the external IP address. So this is the public facing IP address that I need to hit. So to wire that up, I can basically just open up my host headers, my host file. And in here, I've just mapped those different host names. So CD, CM, ID.globalhost to that public IP address. And that's all you have to do. We check these pods now. Hey, there we go. All up and running. So here's the moment of truth. Try CD and CM. So this is going to go over from those host headers. It's going to land in the ingress. That ingress will then have the rule to map that host header to the specific service. Notice I've been kicked over to my ID server now by the CM. We flip back to CD. We can see our beautiful Sitecore, welcome to Sitecore page. The ID auth's happening, and now it's just going to kick us back over to CM. And you can see it's pretty straightforward to get it all up and running. If we look in here, and let me sort by age a minute. Here we have, is this all the pods? 14 minutes, there we go. So 14 minutes from when I first ran my SQL installation, and we have a fully working Sitecore instance, which isn't too bad. So the last thing I want to show is the self-healing stuff, which I think is one of the cool bits, really. So let me just clear that down. If we go and view our pods again, here you can see we have our CD instance. And as we said, Kubernetes is here to basically make sure that the state matches what we've said. So I can go into here and I can say kube control, delete pod, and we're going to remove that pod. What I'm trying to do here is basically mimic an error happening in the container. So something's gone wrong in there, the container's died, and Kubernetes is going to have to replace it. If we hop back to my CD, I should get a 503 now. And the reason for that is that there's no active pod for that deployment anymore. We only set up one of them. If we'd have had scaling there, if we'd have had more than one CD instance, the traffic would have gone over to that other CD pod. If we take a look now, we can go control get pods. We can see we have two of them. The first one's terminating. That was the one up here. So it's just basically cleaning up any dependencies, getting rid of it. And we can see here that the CD instance is starting to be created. It's going through its initialization checks. After they're all complete, it'll start the container, and then it'll bring up the Sitecore instance. This is probably going to take a few minutes to run through. Does anyone have any questions in the meantime while we wait for this?
Hello, this is Ozell. Can you hear me?
Yes.
Yeah, I have one question. You were showing in the YAML file where you had listed the initialization definitions, and they're listed down. So do those happen in sequence? Because I was seeing, things were depending on other things. So are these listed in sequence, and does that control that, or is this like just asynchronous and really doesn't have any impact on when things are initializing and rolling up?
Good question. I believe it does happen in sequence. So the reason for it is we can see that all these containers are actually active. So if they were asynchronous, you'd instantly get all four as reporting as basically alive. But there's a timeout in between the checks. So it's going to do the first check, wait for the timeout, do the next check, wait for the timeout. And I think that's their design just to stop overloading as well from happening.
Great. So order matters in that.
Yes. Yes.
Okay.
Rob, I did have one other question related to the replica set that you mentioned in the dashboard or in the Azure portal.
Yep.
Is that something that Azure or the Kubernetes automatically creates a replica set of the image, or how does that work?
Yeah. That all automatically happens for you. That's basically Kubernetes manages all of that under the hood. You don't have to define any of it.
Okay, that's the one, like as soon as you deleted one of the CD pod, then the replica set is used to create a new one. Is that the way we read it, or?
I believe so. We can go and check. So we have, if we sort by name. So it's one replica set per pod. So per deployment. So it's a shared replica set. Oh, no, because I destroyed the other pod. So we can test it by killing the CM. Let's kill the CM and see what happens. Oh, got to tell it I want to kill a pod. Okay, so that's going to kill that. If we do control get pods, we should have 2 CMs now. Yeah. So if we hop back over to here and sort by name. Yes, we still only have 1 replica set. Yeah.
Okay.
Rob, this is Dheeraj. While we are on the YAML files, you mentioned it's better to have separate node pools for storage containers to the actual application containers. Where do we set those node pools in the YAML files?
So the nodes aren't defined in the YAML. The nodes are created either through, well, usually through the Azure CLI. So basically, if I go here, I have this script which basically goes through and uses the Azure CLI to create my AKS instance. So I basically install the CLI, I create a resource group, create an ACR instance. So AZ ACR create. Then we create our AKS instance. So AZ AKS create. You link your container registry to your AKS instance so it can pull images from there. And this is the piece you're interested in. So here you basically go and have to add a new node pool. So you say node pool, add, it's a Windows type, and these are the size of the VMs. So if you had a separate one for data storage and a different one for data storage roles compared to application roles, you'd have two commands like this, specifying the different VM sizes you'd want for each and the amount of initial scaling you want for both.
Okay, thank you. And we're gonna map those into external container YAML files. We're going to specify the node pool you're going to look into is this. For the storage accounts, for the application accounts, you're going to look into this node pool.
Yes, you'll be able to specify which node pool you want it to go to. Yeah, you do it through labeling.
Okay, thank you.
Let's see how these instances are coming along now. Ah, okay, there we go. So you can see my CD instance is back up now. So if we hop back over here, take a minute or so to warm up. And as I said, obviously, normally you wouldn't run with a single CD instance. You'd have more than one to have high availability. So you'd still be serving traffic at this time. But Kubernetes in the background would maintain the amount of CD instances you want. So the other CD instances would be under a bit more load while Kubernetes does that. But it'd make sure it self-heals. It brings it back to your desired state. Okay. The demo worked. I'm so happy. Let's hop back to the slides briefly. I just want to close on a couple of points. As I said before, Kubernetes got open source back in 2014. It's been around for a while. There is heaps of industry standard tooling out there. Things like that K8 dashboard I showed you. There's many, many other dashboards out there. You can pick the one which best suits your way of working. Just make sure you're leveraging that. There's so much existing knowledge out there. Don't think you have to do things from scratch. Make sure you secure your cluster. So just like you would when you're running PaaS or IaaS instances, this is a production environment. You've got to make sure that it's locked down. And I've talked a little bit about your data storage roles in production, SQL, Solr, Redis. You just need to basically make a plan for how you're going to manage those in production. Whether you're going to create your own images and use those to manage those, or if you're going to use PaaS type application elements like Azure SQL and Azure Redis, you just need to plan how you're going to go about that. For AKS specifically, definitely check out Microsoft's documentation. They have heaps of great stuff there. It's really a really good resource. And also, we open sourced the MVP site a few months back. So we're in the middle of rebuilding that. And if you go to that GitHub repository today, you can get a full CI/CD pipeline for AKS. So it'll show you how you can create a solution for building and developing on containers, how you can then configure Azure DevOps to automatically build those on commit, and on top of that, automatically. Were there any questions while I was missing?
The only question I was asking you to unmute. And I believe Ozal shared some feedback. Ozal, you want to?
Oh, no, I just thought that was very informative, a lot of information. I'm glad it's recorded because I'm gonna have to take time and dissect it and go through it again. But I thought it was a great presentation. Thank you for taking the time.
Thanks. And if you've got any questions, feel free to reach me on either the community Slack or Twitter. Always here to help out.
Thank you.
I might have a question around the Redis. I did not check the Sitecore 10. Is it something new with Sitecore 10 that we have Redis cache like part of the?
I think it's been in the Azure deployments for a while for session management.
For the session management, okay.
Yeah.
And before we used to geo-distribute, if you want to geo-distribute the CD servers, we're going to put them into different resource groups. I'm talking about PaaS environments, but how are we going to distribute now throughout using containers and Kubernetes? Is it availability zones?
You would probably have to set up a different AKS instance in each region, I think. I don't think you can separate the actual VM scale sets per region, because the ingress would have to is basically where the traffic goes into. So you'd probably have to set up a separate AKS instance per region, I believe. You'd have to let me double check that to be sure, though.
Okay. And I have seen something about availability zones. Is that something that comes around this area or something completely different?
I'm not sure about that. That's not something I've looked into.
Okay.
I believe if we are like for that question, I believe if we are doing with Azure, then probably we need to have like a front door kind of a setup where the domain would be pointing to the front door, and the front door would be passing the traffic to different resource groups created in different zones. I'm just talking with the Azure knowledge, nothing related to Sitecore here, but we had a scenario, something similar to this, and where we used front door to do that.
Yeah, I've seen this before in past with using Traffic Manager, but yeah, not sure how to do that with Kubernetes.